Hello all. We just saw in the last video how sequences were not exactly the best way to deal with limits. So what we're going to turn to is a theorem called the limit laws. And the limit laws are going to help us deal with limits in a very quick and effective way. So all we have to do is we have to recognize that the limits of f and g exist, and we can say all different kinds of things about the limits of f plus g, f minus g, of f times g, f divided by g. So we have all of these additional options provided the original limits exist. So let's take a quick look at this. When you're taking a look at the limit of a sum of two different functions, it's just going to be the sum of the limits of the functions. If you're taking a look at a limit of a constant times a function, that constant coefficient can be brought out to the front of the limit, and we just place the limit next to the function and deal with it there. If we want to take a look at the limit of a product of functions, it's a product of the limits of the functions, and so on and so forth. So these limit laws are the way we're going to be able to do limits very quickly, and also we'll also be able to find exact answers, which is fantastic. So a couple of extra things to notice here. Numbers 6 and 7 are a little bit different. So you'll notice that for 1, 2, 3, 4, and 5, as well as with number 8, all of these limit laws, they're ways of taking the limit that happens to be sitting outside of some operation like addition or subtraction, maybe multiplication, maybe a root of some kind. But they're ways of taking a limit that's sitting outside of an operation, and they're the way of moving the limit to the inside of the operation. So you're basically splitting the limit over the addition sign, or you are pushing the limit past a multiplication by a real number. Maybe you are splitting the limit over the numerator and denominator of a fraction, and so on and so forth. So all of these are going to be ways of moving a limit past or through different kinds of operations, except for number 6 and number 7. Number 6 and number 7 are a little bit different, and they're actually very intuitive. So if you ask yourself, for instance, for number 6, if you ask yourself, what should the limit of a constant k be as my x values get very close to a? It should make sense that that limit is going to be k. The constant k is not going to change. It doesn't matter that your x values are approaching a. There is no x anywhere here. It is a constant k. K could be 7, k could be 12, k could be pi. But in any of those cases, there is no x present, and so that constant does not change. And so therefore its limit, as x approaches a, is going to be that constant. So number 6 should make sense. And number 7 is just a very direct statement. Number 7 is saying that if you allow x to approach a, then x is going to approach a. That's all this limit means. So number 6 and 7 are both intuitive, and they're a little bit different, and they're actually what get the job done. But we'll need some of the others to get to the point where we can use 6 and 7. 6 and 7, we will be using those last. So let's go ahead and take a look at this in practice. So let's kind of change away from this worksheet that you have from your packets, and we'll try all of this stuff on an example. Okay? So our example here is we want to be able to use the limit laws on x squared plus 1 all over square root of x as x approaches 3. And so the limit laws are going to tell me that I can take this limit and I can sort of move it from sitting in front of all of these operations. And what I want to do is I want to take this limit and I want to put it next to the x here, and the 1 there. I want to place it next to constant terms or place it next to the variables. That's what I want to do. On the way, I need to get past this division, I need to get past this squared, I need to get past the square root, and I need to get past that addition sign. I need to get past all of that stuff, and so I'm going to use the corresponding limit laws to do it. Number 4 will help me get past the division, number 1 will help me get past the addition sign, number 8 will help me get past the root, and number 5 will help me get past the squared. So we are able to do all of these things. So let's go ahead and try it out. So back over here, and so this is all going to be the same thing as we make a fraction, and this is just going to be the limit on the top of x squared plus 1 all over the limit of square root of x. And both of these limits are as x approaches 3. And what we did here is we used on the limit law, we use number 4 to do this. So this is all because of number 4, right? So moving on, we still have this fraction bar here. And we're going to, for the top limit, we're going to be moving this limit and we're going to be splitting it over this addition sign right in the middle here. And so this is going to be the limit of x squared plus the limit of 1. And of course both these limits are as x approaches 3. Likewise, in the denominator we're going to be using a limit law to move this limit past the square root sign. And so we are going to move the limit past the square root sign, and this is going to be the limit of x as x approaches 3, all beneath the square root, right? And so which limit laws did we use here? Well, we used 1 to move ourselves past the addition sign, and we use limit law number 8 to move past the square root. So that's going to be 1, 8. We use both of those simultaneously. Okay, next. The only thing that I haven't yet accomplished as far as moving my limits is I haven't placed this limit directly next to this x. There's still this square that's between my limit and my x. This limit is sitting next to the 1, this limit is sitting next to the x. And those are exactly the places I want those limits to be. So this is the last term I have to deal with. And so I'm going to use another limit law. And this is going to be, and I'm moving this limit inside of the squared. So the squared is now sitting outside the limit. Of course, this limit is still as x approaches 3. The others I'm just leaving alone. This is still the limit of 1 as x approaches 3. And this is still the square root of the limit of x as x approaches 3. So we're now ready to finish the job. So you'll notice my limit is always sitting next to an x or it's sitting next to a constant. So this allows us to use 6 and 7. 6 tells us that if our limit is sitting next to a constant, that just transforms into the constant itself. And number 7 says if our limit's sitting next to the x, all of that transforms into whatever number the x is approaching. So let's go ahead and try it out. Because this limit is sitting next to the x, this whole thing is going to be 3. So this is going to be 3 squared. And this is going to be plus, and this limit right here is sitting next to a 1, so this is just going to be 1 divided by, and this limit down here is sitting next to the x, and so this whole thing turns to a 3, and there's just a square root of 3. And this entire thing is going to be equal to 3 squared, which is 9, plus 1, which is 10, all over the square root of 3, which you may remember from our previous video. And so all we did here is we just used 6 and 7 to finish that job. And if you look, you'll notice something that may be kind of interesting. So you see this x squared plus 1 all over square root of x. All we really did between here and here is we just took that 3 down here, this limiting number, and we placed the 3 into the function, and we ended up getting something that looks exactly like this, and we're able to figure out what the limit is very, very quickly, very, very easily. And so the limit laws, we will not usually be doing all of these steps whenever we use the limit laws. In fact, the limit laws are going to usually work in the background. Usually when we use the limit laws, this is what it's going to look like. We're going to try to find the limit of x squared plus 1 all over the square root of x as x approaches 3. The limit laws are usually going to look like this. We are just going to go ahead and put the 3 in on the top and the bottom where the x's are. And when we put the 3 in on the top, we're going to get 3 squared plus 1. On the bottom, we're going to get square root of 3, and that's, just a second, we do not need this limit here. There we go. So apologies. So when you put the 3 in, the limit goes away, and when you put the 3 in, you get 3 squared plus 1 on the top, square root of 3 on the bottom, and that's just going to be 10 all over square root of 3. And this is what we ended up with. This is what you will usually use when you are going to be using the limit laws. The limit laws are something that happen in the background, and they're an excuse for us. They allow us to put the limiting number in, and if it works, we get to keep the answer. There are many, many important cases where the limit laws don't automatically work when you put the number in. But when they do work, you're finished. And in fact, many of those cases where the limit laws don't work, most of our job is to change the limit so that the limit laws will work. And that's really a topic of a future video. So thanks for watching, and again, happy mathing.